Good morning, 6th grade. This is lesson 16 from module 3. Lesson 16 is symmetry in the coordinate plane. This word right here, symmetry, just means a mirror image across a line. Okay, so in this case, we're going to be talking about lines of symmetry. Lines of symmetry is something we went over a little bit in 5th grade. Basically, it means that when you have an imaginary line or an actual line, you can mirror a point from one side to the other. Okay, so that's what symmetry means. So I pre-wrote some of this stuff because I didn't want to spend majority of my time recording just me writing. So I did pre-write some of this stuff, but I will still go over it. Okay, so in our opening exercise here, it says give an example of two opposite numbers and describe where the numbers lie on the number line and how are opposite numbers similar and how are they different. So you could come up with any numbers you'd like. I just did 2, -2, and basically both are 2 units away from 0 in opposite directions, or both have an absolute value of 2. Similar with the same absolute value, of course, but on different sides of the 0. Okay, so now let's go into example 1, extending opposite numbers to the coordinate plane. So I went ahead and pre-plotted all of these points already onto this little coordinate plane that they gave us here. Locate and label your points on the coordinate plane to the right, so you're going to do that as well. For each given pair of points in the table below, record your observations, so what you see, and conjectures in the appropriate cell in the appropriate spot. Pay attention to the absolute values of the coordinates and where the points lie in reference to each axis. Okay, so we had 3, 4, -3, 4, 3, -4, and -3, -4. So I plotted all of the points, okay? And they want us to talk about the similarities of the coordinates, the differences of the coordinates. If you look at the next cell, I think it was location. Actually, let me just show you here. Similarities in location, differences in location, and the relationship between coordinates and the location on that plane. All right, so first we're gonna go ahead and take a look at 3 and -3, 4. So that's here, 3, 4, and -3, 4. So what's the similarity? They both have the same y coordinate, okay? And the x coordinates have the same absolute value because they're both 3 units away from the y-axis, okay? The difference is that the x's are opposite. The location is that this one is 3 units to the right of the y-axis. This one's 3 units to the left of the y-axis, but they're both 4 units above the x, okay? And the differences in location is obviously that this one is 3 units to the right, this one's 3 units to the left. And what's the relationship between those two? The relationship between those two is that the x's are opposites. So they're on the opposite sides of the y-axis. They have the same y, which means their line of symmetry, they're symmetric along the y-axis here. So they mirror each other from the y-axis. Let's look at the next set of points. So we have 3, 4, and 3, -4. So here's 3, 4. Once again, they're all being compared to this first initial point right here. Okay, so 3, 4. 3, -4 is just going down this way. So what's the same in those? They have the same x coordinate and the y's have the same absolute value. They're both 4 units away from the x-axis, okay? The y's are opposite, meaning this is 4 units above, this is 4 units below, and the similarity in location is that they're both 4 units above and below the x-axis with the same x coordinate. And because they're different or opposite y's, the relationship between the two is that they're symmetric along the x-axis. Okay, so I just went through all of the cells for this one set, but that's basically all I'm saying. So feel free to not have to write all of this down, but I'm just showing you the relationship so we can move on to the exercises, okay? And then we have 3, 4, -3, -4. So here's the one that's the most different, honestly. We have 3, 4, which is right here. and -3, -4, which is over here. Okay, so these are not symmetric along any axis. It kind of reflects to the opposite, then it reflects again. So for this one, the similarity in coordinates is that the x's and y's have the same absolute value. That's the only similarity, okay? The x's and y's are opposite, okay, which is why they're completely on the opposite ends of this coordinate plane here. So the similarity in location is that they're both, the absolute values make them the same amount away from the axis, but that's pretty much it. Aside from that, both points are 3 units from the y, and both are 4 units away from the x. The difference is that one point is 3 units to the right of the y, while the other is left. One point is 4 units above the x, and the other is below it. X's and y's are opposite, and they lie on opposites of both axes. Okay, so they lie on the opposite of the x as well as the opposite of the y. So that's why it's like across from each other, okay? So this, why is this so important? Let's go into this first exercise here. In each column, write the coordinates of the points that are related to the given point by the criteria listed in the first column of the table. Point S, 5, 3 has been reflected over the x and y axis for you as a guide, and its images are shown on the coordinate plane. Use the coordinate grid to help you locate each point and its corresponding coordinates. Okay, so let's take a look at this first point, 5, 3, which is S, and it's already conveniently plotted for you and labeled. They want us to find the given point that is reflected across the x-axis. So the x-axis is this right here. So what point is reflected on this axis? So reflected on the other side of this line. So that means from this point to the x, we have 1, 2, 3 points. So now we're going to look 3 points down to see which point is reflected. 1, 2, 3. So what point is that? That is point M. Okay, so now we have to do the same for -2, 4. -2, -4, 1, 2, 3, 4. -2, -4. So which point is reflected across the x-axis? Well, this point here goes 1, 2, 3, 4 points below the x-axis. So we need to look for the point that's reflected 4 points up. So that's 1, 2, 3, 4. So that would be -2, +4 is the point reflected across the x-axis. Sorry, guys. Need to look at my guide here. Now let's do it for the next point. 3, -2. Here's 1, 2, 3. -2 here. So 2 points down, we're looking for the point reflected across the x, which is this line. So this point is 1, 2 down from the x-axis, so we need to go 2 points up. 1, 2, right here. So that's 3, 2. Now let's do it for the last one. -1, -5, -1, -5, 5 points below the x-axis, so we need to go 5 points above it to reflect the other point. So that would make our reflection point -1, 5. So I want you guys to notice what happens to the y coordinate, because that's the one that gets reflected over the x-axis. It's just the opposite of the y coordinate that they listed. So -5, 5, -2, 2, 4. Sorry, did I do? Oh, I didn't list this one right. It's -2, -4. There we go. All right, so now let's look at point S again. And now we want one that's reflected across the y. So here's S. Remember, S is 5, 3. And now we're looking for points reflected on this axis here, the y-axis, okay? So we look at where S is in reference to the y. So that's 1, 2, 3, 4, 5 to the right. So now we're going to go 5 to the left, right on that same x-axis. So 1, 2, 3, 4, 5. So what's the reflection point for S across the y-axis? That would be L. All right, so now let's do the same for negative 2, 4. So we had negative 2, positive 4. So from the y, that's 2 points this way, so 2 points to the left. So now let's go 2 points to the right of that on that same line. 1, 2. Here's the reflection point, which is positive 2, 4. All right, now let's do the same for 3, negative 2. 3, negative 2. We're reflecting across the y-axis, so that's 3 points to the right. So now we're going to go 3 points to the left on that same line. 1, 2, 3. So that makes this negative 3, negative 2. So now for the y-axis, what do you guys notice? We're going the opposite of the point again, but now for the x. So that means we can expect that for negative 1, negative 5, the opposite reflected across the y-axis will be positive 1, negative 5. Let's see if I'm right. So negative 1, negative 5. So 5 points, 1 point to the left of the y-axis. So now we got to go 1 point to the right. Was I right? Positive 1, negative 5. All right. The given point, so now I'm looking at the next criteria here for the point S. The given point is reflected first across the x-axis, then across the y. So we know for S, first across the x-axis would be M, and then on the opposite side of the y. So going from S to M, and then the opposite on the y would be point A. So now we're going to do the same thing for all our other points. So negative 2, 4. Negative 2, 4. Reflected first across the x-axis. We already did that. Reflected first across the x. Here's the x. We did that one, which is negative 2, positive 4. And now across the y, here's 2, 4. Okay, first across the x. Sorry, I need to make sure my work is correct. Negative 2, 4. Reflected first upon the x-axis. Sorry, it's this way. And then across the y. I went the wrong way. Sorry about that. It would be positive 2, negative 4. Because we have to go from the first point that they gave us, which is negative 2, 4. So here's negative 2, 4. Reflect it first across the x. So that's here. Then reflect it across the y. This way. Okay? First reflect on the x-axis. So go from here. Reflect along this line to here. Then reflect across this y-axis here. Sorry, I know that's a lot of steps. Let's try that one with the next one. 3, negative 2. Okay, positive 3, negative 2. So reflect first across the x-axis. So that's this line here. We already did that. Here's that one. And now across the y. So 3 units this way. Now we go 3 units to the left. 1, 2, 3. So that would be negative 3, 2. All right. Negative 1, negative 5. Here's negative 1, negative 5. Reflect first across the x. Boom. Now across the y. Okay. So 1 unit to the left, 1 unit to the right. That would be positive 1, positive 5. All right, now let's do this last set for S. So the given point is reflected first across the y, then across the x. Okay, first across the y, so that's this line here. So first across the y, boom, now across the x. So now this way, which is point A. All right, -2, 4, -2, +4. Okay, first across the x, sorry, first across the y. So that's this way. Then across the x, 4 units up, that means 4 units down. So that's 2, -4. All right, let's try it for 3, -2. Okay, first across the y, 2 units to the right, that means 2 units to the left. Sorry, 3 units to the right, 3 units to the left. And then across the x. 2 units down, 2 units up. So that's -3, 2. I want you guys to start noticing something. Aren't these points the same as these? Okay, if you reflect across both axes, you're going to come across the same point. So -1, -5, -1, -5. First across the y. Okay, that means 1 unit to the left goes to 1 unit to the right now. Now across the x, which is this line, 5 units down. So we go 5 units up. We go +1, +5. And I was right. Reflects the same points as this. When you go across both axes again, you come across the same 2 points. The same point, sorry. All right, let's take a look at exercise 1. When the coordinates of 2 points are x, y, and -x, y, what line of symmetry do the points share? So I put numbers to it just to give you an example. So let's say this was 1, 2. That means this would be -1, 2. What line of symmetry? That means what line is cutting them for reflection. So if I put that on this coordinate plane down here, so 1, 2, I'm not actually going to plot them. I'm just going to show you. So here's +1, +2. -1, +2 would be here. So what line of symmetry is this that they share? That would be the y-axis. So when the x's are the opposite, they share the y-axis as a line of symmetry. Okay? So what's going to happen if the opposites are now the y's then? Well, let's take a look. 1, 2, here, 1, -2. So now what line of symmetry are they sharing? It's this one. So when the y's are opposite, the line of symmetry they share is the x-axis. Got it? All right, so for examples 2 and 3, we're gonna use this coordinate plane. I am gonna plot the points. You don't necessarily have to, but I find it easier if I see the point on the coordinate plane. So I'm gonna give you some set of directions, and I wanna see how you do with this. I will plot them, but like I've said before, you guys can feel free to pause the video as you need to, check your answer, and then come back to the video so that way you could see if you did it correctly. So we're gonna begin at 7, 2. So that's +7, so 1, 2, 3, 4, 5, 6, 7. +2, that means you go up 2, 1, 2. All right. So here's 7, 2. If we move 3 units down and then reflect over the y-axis, so I'll label these once again. So here's the y-axis, here's the x-axis. So if I move 3 units down, 1, 2, 3. I'm going to do this one a little more faint. And now I'm going to reflect across the y-axis. So that's this line right here. So that means I'm 7 units to the right. So I'm going to go 7 units to the left. 1, 2, 3, 4, 5, 6, 7. What point am I at now? Move 3 units down and reflect across the y-axis. So that's -7, -1. Correct? All right, let's try another one. we're going to begin at 4, -5. So that's +4. So to the right 4. 1, 2, 3, 4. -5. So that's down 5 units. 1, 2, 3, 4, 5. So here's 4, -5. And from here, I want you to reflect over the x-axis. So here's the x-axis. 5 down, that means I had to go 5 up. 1, 2, 3, 4, 5. And then from here, I would like you to then go to the right 2 units. And now where are you? 1, 2 to the right. What point is this? So I know this was 7, so this is 6. And I went 5 units up. 1, 2, 3, 4, 5. Yeah, so 6, +5. All right. Now let's do another one. We're going to begin at -3, 0. So -3, 0. That's left to the to left 3. 1, 2, 3, and 0. That's right on the x-axis. Reflect over the x-axis. If we reflect over the x-axis, can we do that? No, we can't, because that's we're already on the 0 on the x-axis. So if we reflect, we're still right here. Okay, and then move 6 units to the right. 1, 2, 3, 4, 5, 6. Okay, reflect over the y-axis. Well, isn't that just going to go right back to where we started? And then move down 3 units. 1, 2, 3. Where are we now? We're at 3, -2. I'm sorry, 3, -3. 1, 2, 3. All right. Okay, guys, so in closing, a line of symmetry is a point, or I'm sorry, a line that makes a mirror of both points. Okay, so if I tell you to reflect over the x-axis, that means however many digits down from the x-axis, you reflect that point above it. If I tell you to reflect over the y, that means however many units to the right of the y, you go that many units to the left, and vice versa. Okay? All right, guys, that's it for today. Danny's upstairs playing with his dad, so no Danny outro today, okay? But he'll be back tomorrow. See ya.